just going to reiterate the problem for anyone who's not here, who's going to be watching on YouTube, which is we are trying to write a function that rounds a value to the next multiple of 10 of its rightmost digit, right? And then we're writing a function that takes in 3 arguments and adds the sum of all rounded numbers. And then finally, a function, update the function to take in any number of arguments. Oh, I thought I was screen sharing. Anyway, let's talk about, so what went well, what didn't go well, what did you try, what did you think, how far did you get? Floor is open.
So I guess like where I was like getting a bit stuck is trying to write a conditional statement that would sort of like I didn't want to write like you know, like I know it was suggested we write like a helper function that would sort of take in you know, take in like a number and like round it for us and stuff. I guess I was trying to find a way to make the logic so it's like, okay, cool, if b is greater than 5, then I'm going to round it up. If it's less than 5, then I'm going to round it down. Do it for all 3 and just add it all. So I guess it's just like writing 3 conditional statements and adding it together. But I feel like something's missing in that approach, and I'm trying to, I don't know, like I was trying to think about how to go about doing this. I'm still trying to figure. The first thing I tried even doing was maybe making the helper functions like closures, but I sort of forgot how to like write them, like have something like round up or something. But you know, I think that would be kind of cool to see if I could figure out how to write it like that. But like I don't know, I'm still sort of like thinking through it. So yeah.
Okay, that's cool. Anybody else? What else did we find? What's going on, everybody? Nobody has any thoughts. Oh, don't make me randomly call on people.
So the way I went about it was kind of like broke it down how you had it. So the function takes in a spread operator called arguments. So that's going to be the 3 variables and so on, and whatever you pass in. And then I'm going to declare my sum. So at each instance, I'm going to look for the first digit. And if it's greater than 5, this is where like I did it the long way, I guess. If it's greater than 5, then I added 1 until that number mod 10 is divisible by 10. Else I subtracted until that number is divisible by 10. And then when I found that number, I added it to my sum. Then I just returned my sum.
Ah, okay, makes sense. That's cool. How did you isolate the last digit?
So I did. So there was 2 ways. I did it by the string, which I kind of didn't really like. So I was trying to find a different method. So I was thinking like dividing it, modding it by 10 and then dividing it by 1.
Cool. Makes sense. I don't think you would need to divide it by 1 though after. But besides that, I think that makes sense. Any other approaches? Thanks, Doug, for sharing that approach. Okay, well maybe people will get a little more chatty as I chat. Thank you, Marvin and Doug, for both sharing. Really appreciate that. Okay, so let's just take this, you know, one step at a time, right? So it says write a function that rounds a value to the next multiple of 10. Okay. if its rightmost digit is 5 or more, it should round up to 15, rounds up to 20. Alternatively, round down if it is to the previous multiple of 10 if it's in the rightmost digit. It's less than 5. So 12 rounds down to 10. Okay, so we can write this function, right? So what are some ideas for this? Doug gave us one. I guess Doug gave us two. Well, what were some other? Did anybody do anything different?
Yeah, I did like an if statement and took the value, like the integer, and did modulo 10. And then I compared that value to if it's greater than or less than 5. And then, yeah.
Yeah, keep going.
And then from there, I, if it was less than 5, then I removed the last digit and then added a 0. But if it was greater than 5, I removed the last digit, did plus plus to the like remaining digits, and then added a 0, and then return that, if that makes sense.
Yeah, how did you remove the last digit?
So I kind of Googled this because I was stuck with it as well, but I did value dot toString dot substring, and then, I mean, I don't know. Should I just share my screen? Because I really am not.
Yeah, I'd love to see.
All right, give me 1 second. Okay. So right here, line 7.
I see. So you're essentially just slicing or substringing.
Yes.
After turning it into a string to remove the last digit. Cool.
Mm-hmm. Mm-hmm.
String conversion.
Yeah. Yeah.
Thank you.
Okay.
Very cool. Any other approaches? Okay. So yeah, so there's a couple cool things. Let's just talk about these as in like for practice sake. So like, let's say we have a number. So we can do any number, right? Like 324. So there's a couple tricks that you all should learn and feel comfortable with because sometimes they show up in different problems. So if we want to isolate the rightmost digit on any number, you can mod by 10, right? Which we saw that in Sam's if else. Oops, I don't know why I did 10. There we go. I don't know why I did 4, but anyway. So let's just run this to see that this will actually give us back our 4. So this is node, say, 1. Right, and so we can isolate our 4. Now, if we actually want to isolate everything else without the 4, then you can divide by 10. And round down, sorry, math that. So if you just want the 32, that's another way to go about removing digit. So because our numerical system is based around base 10, you can most easily like drop and get certain integers in their places, right? Because it goes like 10th place, 100th place, 1000th place. You can control all of those things usually by doing some kind of math with the number 10, either modding to get the last or dividing to get the rest. Does that make any questions on that math?
Yeah, that makes sense. That's cool.
Yeah, it's kind of cool, right? So if we think about it like that, right, we can isolate our rightmost digit. So we can say const, right digit. And with that, we could say that is num mod 10, because that's going to give us whatever is the rightmost digit. So then, like same with Sam's if statement, is right. We can check to see how this compares. So like if our right digit is greater than or equal to 5, well, then we need to get this number up, right? We need to get this number up by some amount. So there's a little math we could do here, which is, so let's say this was 5. Our right digit was 5, and we needed to go up, bring it up to 10. Is there, how do we know when our number is 5 and our final solution should be 10? How do we know that we need to add 5 to it? Right, so if, let's say num is 5, should be 10. What do we need to add?
It's got to be 5 because
Add 5.
We need to add 5. Everybody got that, no problem. Okay, so what about if this number was 7? What would we need to add?
Add 3.
Okay, so what's the math that everybody's doing that is making it so easy for them?
You would subtract the num from the next number up.
Okay,
Subtract 7 from 10.
so 10 minus 7, you said, are saying, right? So 10 minus 7, and then if we wanted, and then then we'd have our 3. So if that's what we need to add, we could just do 7 plus, right? 7 plus 10 minus 7, and that would give us 10. Does this work for other things? Like if this number was 26, we would know that our number should be 30.
But aren't we looking at the second digit, not the whole digit?
Exactly. We're only really looking at the second digit. So if our number is 26, we only really care about 6, which means we only need to bring it up to 10, which means we only need to add by 4. And so then these work. So if our right digit is greater than or equal to 5, we can just return our number plus 10 minus our right digit. Do we agree with this?
So we're just essentially just adding the difference, right? Just to make sure we get to that nearest 10.
Yeah, because we need to get to a 10.
Yeah.
We know what we have. So we just get the difference between where we need to go and what we have, and then we add that to our number to get to where we're going.
That makes sense.
Take it in for a minute. Make sure you understand it. Since this is really a one-line thing, I'm just going to move it up. It doesn't really need to be on multiple lines.
Yeah, and that works out because we're only looking towards that like singular right digit, right? Like it's literally it. Like we're just checking to see if that one right digit is bigger than 5 or if that's 5. So,
Exactly.
okay, cool. That makes more sense. Yeah.
But this only works if the second digit is higher, if it's 5 or higher than 5.
Exactly. So we need to write a statement for when it's less than 5, right?
Yeah.
So if we're good with what we do when it's above 5, then let's go ahead and figure out what exactly do we do when this is less than 5. So if our number is 23, what number does it need to go to?
30. I mean,
Almost. It's got to go down to 20, right? Because we got to round down.
that's what I said. 20.
So what do we need to subtract from 23 to get to 20?
The right digit?
Yes, exactly, right? I'm so happy you actually said the right digit, right? Because we could say 3, we could say 2, but really what we're doing is we're subtracting our num minus our right digit.
Does that make sense? Yeah, because like if for 23, it would just be like 20 minus what we're doing is 3, really? Or 2 minus 3.
So let's go ahead and test these. So we'll say round, and we'll say 27. We'll round 32, and we'll round 19. Yeah. Okay, and we get 30, 30, 20. Okay, so this is behaving the way we're expecting it to behave. And I think this answers part 1. Any questions on this? Okay, if not, then let's keep going. So let's take a look at part 2. So we have a function const called round sum, and this takes in 3 arguments. We'll say A, B, and C. And this is going to round all of them and then return the sum of all of them. So we could say round A plus round B plus round C, right? And this hopefully will work. Let's try it. All right, that's the most kind of straightforward one. So we'll say 27, 17, 32. And it gives us 80. So that's good because this would be 30 plus 20 is 50 plus 30 is 80. Okay, so now we've got our part 2. But this isn't super flexible, right? So the moment we want to update our function, so like what if I really want to also pass in 9, right? So now I want 90. And if I do this, well, we're stuck at 80 because we're only doing the first 3. So I could add a D, but it's just not flexible. So I don't, so how can I update my function so that it can take any number of arguments? What do I do for something like that?
Args?
You want me to write args?
And the spread operator?
And the spread operator. Okay, I like that, right? So this is args, or I could call it array, right? I can call it anything. I just want to make that clear, right? Because this is all of the arguments. So yeah, I can call it arg. But when I deal with it here, it's an array. So we can like first just prove that to ourselves by logging our args. Right, and we get our 27, 17, 32, and 9. So now it's a matter of summing the this. It's a matter of calling round on every element and summing them together. Is there an array method that would be the best to use in this situation?
Oh,
I'm sorry, you cut in after you had said most of what you were saying.
oh yeah, sorry. I was trying to see whether or not we wanted to just use like for each for like a side effect sort of
Okay.
thing.
Sure,
Um,
a lot of for eaches. Let's do it.
Yeah.
So let's start with that. So we'll say let sum, right? And then we'll iterate through our args. So args dot for each, and we have our element and plus equals round of our element and return sum. Okay, looks good. Let's see, do we hit our 90? We do. So this completely works. Oh, Doug's saying something else. Yeah, is there an array method that would be even better than for each? So yeah, Brutus, yeah, Doug, right? So people are saying reduce, or the array method is actually just called reduce. Right, so reduce works really well because reduce can do the same types of things at the same time. So and it would give us an opportunity to review reduce, which would be really cool. So let's go ahead and do that. So we have our args. We'll call, whatever I get back is what I'll be returning. And we'll call reduce. So reduce takes in a callback function, as well as a starting initial value. So what's a good initial value when you're going to be adding everything up?
0.
Zero.
Yeah, 0 sounds good. And so this callback function, if we remember, takes in what two arguments?
An accumulator and
Accumulator and what?
The element.
Yeah, and the element, right? Or the current element or element, right? Because we're still iterating through it. And the accumulator is whatever is going to be returned from the last reduces iteration. And in the first iteration, the accumulator will just be
the initial
our
value.
initial value. So for this problem, if I wanted to make it look more like for each, I could call this sum, which is going to start with the value of 0, and we have our element. So I could just return sum plus our rounded element. And if I do that, we also get 90. And since we're not really doing much on one line, we might as well make it one line and do an implicit return. And at the same time, we could make this one line and do an implicit return as well. And it should still work. Right? Remember, if we take away the curly braces, we just automatically return what's inside. So since we're not doing any kind of logic, and we're just returning straight up what we get, it's a good opportunity to do that. So just to reiterate, we are using the spread operator to take in any number of arguments and turn them into an array, which we're calling here. We're using reduce, our array method, which takes in two arguments, a callback function, and an initial value for the accumulator. This argument is optional. If we do not supply this argument, the accumulator would be the first element in the array, and we would start iterating on the second element. It's best practice, though, to generally provide an initial value for your accumulator. It's our accumulator. In this case, we're calling sum because that's what it is. This is our first element of the array, and we're just returning whatever our sum was from the last iteration, plus whatever we get back from rounding our element. And that's all she wrote. That's all it is. Any questions on how this one's working? Okay. So there's one other thing I want to share, just because I don't know if we ever even covered it because we're short on time. This is not a big thing, it's just a small bonus. So if I were to write back in old ES5 style, right, and I wrote a round sum, I should have to take in arguments, right? And let's say I don't know how many arguments before the spread operator existed. What you would do is not act like it doesn't take in anything. And JavaScript has a built-in something called console log, which is called arguments. It's actually a key word. And so when I run this, you'll see we actually have this arguments. Right, so arguments is a key word in JavaScript and was really used a lot more before the spread operator. And all that did was create this arguments object of all the arguments that are passed in. Now, what do you notice about this arguments object? What's something we notice?
It assigns its own keys.
Sorry, Fowler?
It assigns its own keys, like as if it were an array.
Yeah. Yeah, that's exactly what I was going for, right? This has its own key value pairs. It looks a lot like the key value pairs are all kind of array indices, right? Like 0, 1, 2, 3. But it's very important to realize that this is not an array, right? I cannot do arguments dot for each. I cannot do that. If I try, we'll see what happens, but I'll write like the way we did the problem before, right? We had sum equal to 0, and we did arguments dot for each element. We'll say sum plus equals round of element, right? And then we'll return the sum. That's essentially what we had before. It's gonna throw an error. It's gonna say arguments dot for each is not a function, but that's because for each is not an object method. So if we wanted to iterate through this, we could use a for loop though. So we would say I equals 0, while I is less than, because arguments actually does, this is a little different than an object, right? It does have a length property still.
I was just about to ask that. I was just like, how are we iterating through this with a for loop, with a regular for loop?
Whose voice is
Oh, that's me. I'm just tired morning.
that?
Yeah.
Oh, nice.
Yeah, I was like just about to ask that. I was like, how it doesn't have a length. So I was like, but I guess it does. So.
And so I'm pretty sure it actually does. I haven't used it for a while. But yeah, so arguments should have a length property. So in that case, we just say sum plus equals our arguments, and we can key into it at our I. And then we also want to be rounding that because that's the problem. And if we do it like so, we should also get 9. So this works as well. I'm loving the chat. Hey, Marvin. We just gotta. Okay. So I just wanted to make sure you've seen this at least. It's a little bit, although you probably won't really ever need to use arguments very much. It's good to see that this is definitely a piece of history, right? This came before the spread operator. This was the way of handling numerous arguments that you didn't know about, you could just use this arguments function. However, in today's world, this is the better answer. But prior to today's world, something like this is how you would have been doing that. Arguments is not actually an array, although it does have a length property, and it's built in. So that's why also, I don't know if you've ever tried, probably not because it's a weird name, but if you can't really like have a variable named arguments because it's a key word. It's like, you can't have a variable named continue or break, right? Those are all key JavaScript words. So any questions at all? Okay, and yes, I will push the code. I'll do that right now. I should type things in. Henry says third part. This is the third part. The third part is to have it take in any number of arguments. Oh yeah, no problem. Okay, so if there's no other questions from now till lunch, let me stop the recording.